All right, so we're on this 2006 Corolla for our fuel injection lab. We're looking at the powertrain management diagram. Have both the fuel pump and all the injectors on here. As you can see, we have an EFI relay inside of the engine bay, fed power hot at all times. That relay then feeds the load side of that relay, then feeds over to this other relay in the instrument panel, which feeds power straight to the fuel pump. And the ignition switch is what is responsible for feeding power to all the injectors. Follow this all the way over here. You can see all the injectors get their power from this wire coming from the ignition switch, and then they all are ground side controlled by the PCM using pulse width modulation.
So here we are in the back of the Camry looking at the fuel pump, showing that here is the vent hose and then the output for the returnless electronic fuel pump system. And then we're going to be back probing here with our red and black wire as the power, and then the white and black as the ground. The key is in the on position right now, and we're getting nothing because that's millivolts, it's just low. And then if you turn the car on, there is our 13 volts battery voltage.
So on this Corolla, it is a port injection style injector here. We're ohming out the injector. It currently has 12.5 ohms going through it, or has 12.5 ohms, so it is within spec. And that means that with about battery voltage at about 12.6 or 13 to 15 when it's running, that means the injector would be drawing about 1 amp of current. All right, so on this Corolla, we are picoing the injectors now. We have one of the leads hooked up to the ground side of the injector, the driver's side going to the PCM, which grounds it, as well as one of them on the ground side of the battery. As you can see here, we have the waveform pulled up with a trigger here so that we can see the live data. Cleans it up a little bit too, but it also keeps it in the middle of the screen, a good place for us. But you can see here, when the injector's not on, it's being fed about a constant like 8 volts. When the PCM ground side turns on that ground side driver, it turns on the injector as well, which you can see here, it drops down to 0 volts. And then once the PCM turns the injector off, because it's an electromagnet, it collapses and has a voltage spike up to about 60 volts. You can see here as well, we have a pintle hump from the injector seating back down and closing mechanically.
Okay, we are going to increase the engine's RPM and see what happens on our graph. And as you can see where the ground side driver is, it lengthens because the fuel injector is dumping fuel for a longer time of the duty cycle.
All right, so we're still picoing the injector on the Corolla. We're gonna go ahead and add propane to the airbox, give it a lean condition, see what that does to the waveform of the injector. As you can see here, the pulse width's starting to widen up. It went very lean. We actually stalled out the car as well, so yeah.
So here we are measuring the voltage drop of the injector. As you can see, we are getting battery voltage, and if I push the minimum maximum button, you're seeing that we're getting 22 volts at our maximum, and 0.183 is our minimum when it's dropping down on that driver circuit to ground the injector to spray fuel. Gas. And as you can see, nothing really changes there.